The earth is my home. I promise to keep it healthy and beautiful. I will love the land, the air, the water, and all living creatures. I will be a defender of my planet, united with friends.
My name is Commissioner Frank Avila, and I'm a commissioner at the Metropolitan Water Reclamation District of Greater Chicago. And the name of our show is Healthy Community Through Green Infrastructure. And today I have as my guest, I have Steve Weiss. He's the program manager for natural resources. Steve has his Bachelor of Science in History from the University of Michigan and a Master of Science in Space Studies from the University of North Dakota. He's been away, he was born here in Chicagoland area, raised here in Chicago land in Winnetka, Illinois. And he's been away for about 15 years, and the last 10 years he's been up in the Pacific Northwest doing water conservation and river and forest restoration and education. And he's back here in Chicago working for Center for Neighborhood Technology, and he's bringing all this knowledge that he learned while he's been away trying to save the planet. And we're fortunate to have Steve here in the Chicagoland area to implement what he learned for the last 10 years up in the Pacific Northwest. Glad to have you on our show, Steve.
Thank you so much, Frank. It's a pleasure to be here.
Steve, you manage the Natural Resource Program at the Center for Neighborhood Technology. Tell us a little bit about the organization and your program that you're doing there.
Well, sure. The Center for Neighborhood Technology is a 30-year-old nonprofit, a private nonprofit group here in the city. Occasionally we get confused with the Center for Green Technology, which is a city program, an excellent program at the City of Chicago, but we are the Center for Neighborhood Technology, or CNT.
CNT?
Right. And CNT's work is all about sustainable communities, particularly in urban areas, and we say sustainable communities and attainable results. So what we mean by that is that we're looking for strategies that help communities to lower their environmental impacts while increasing their economic viability, things that save people money and improve environmental conditions. So my program, the Natural Resources Program, is all about looking for opportunities like that, having to do with water, air, environmental impacts directly, and the resources that we all depend on, even as we're living in a city.
Now, you mentioned Center for Neighborhood Technology has been in existence for 30 years. 30 years ago, were they in the natural resource area for technology, or were they started in other technology?
Well, it's always been a mixture of different issues that CNT has approached. When we say technology, it's as much the way that we organize things as it is a particular machine or a gadget or something like that. So the idea is that the way you organize activities in a neighborhood or in a community, that's what affects how much it costs people to live, the quality of life in those communities, and how you can actually do things that improve the environment while increasing economic opportunity.
So 30 years they had this vision of the environment, protecting the environment.
Absolutely, and the idea that the most effective things that we can do are going to be things that are affordable for regular people, because if it's unaffordable to do, it's going to be hard to get people to get behind a solution, even if it's a good environmental impact.
Well, you know, that's great that we had, was it one person or several, to vision 30 years ago that we need something like Center for Technology.
I think there was a number of people. Scott Bernstein, who's the president of the group now, was there at the beginning, and there were a few others that came out of a program that they had been working on at Northwestern University. They realized there was this need for applied research. CNT considers itself a think and do tank. So we do research, we look for demonstration projects where we can explore a solution, and when we find one that works, we try to expand that and scale it up to entire communities and entire cities. And the project that we're working on in my program is called Green Infrastructure.
Green Infrastructure. Now why do we say green? Why don't we say blue?
Well, in this case,
or clear?
sure, it's an approach where trying to take advantage of the natural resource of clean water when it appears as raindrops, or catching raindrops where they fall. Right now, the way that we deal with rainwater is it turns into stormwater. It runs across roofs, runs across streets or sidewalks, what are called impermeable surface or paved areas.
Yes.
And when it does that, it picks up pollutants and then we try to catch as much of it as we can into sewer systems. So we see that water as a waste product. What we're trying to look at is considering that water as an asset. And the clean water, when it falls as rainfall, is a tremendously valuable asset. Clean water is one of the most valuable things we have. It's a question of how we can keep that water clean and use what we call green infrastructure, plants and soil, built systems like rain gardens and swales and permeable pavement and green roofs and rain barrels to maintain the quality of water, restore and protect and enhance natural drainage so that water stays clean and feeds communities and feeds wildlife, feeds the whole quality of life in a community.
And that's why it's so important that we have green infrastructure.
Right. Green infrastructure is considered a new approach, but it uses very old approaches in terms of just gardening, the power of plants and soil. It's amazing that when you actually run water through, even polluted water, through one of these green infrastructure features, the water comes out clean at the other end. Because
because you mentioned pollutant.
Right.
Before we didn't have green infrastructure in some areas, that you mentioned that the stormwater comes down, a runoff, it runs along the lawn or along the pavement into the catch basin.
Right.
And it's picking up all that pollutant. But you mentioned green infrastructure collects all that pollutant before it goes into any system.
Right. The idea is that you can use even relatively small open spaces to put in a rain garden, to put in a rain barrel, to put vegetation.
What's a rain garden?
A rain garden is a small depression or an excavated area where you put in rock and soil and then plants to collect the water before it runs into a sewer and then infiltrate slowly into the ground. And what that does is it reestablishes kind of the natural function of where rain would normally have gone into the ground, and the biotic community in the soil can actually consume pollutants. It can reduce the amount of things like oil and grease coming off of cars. It can capture heavy metals. It can capture nutrients like fertilizer that are running off of people's lawns, and then digest that into the soil and send clean water out back into rivers and lakes and waterways.
Do you have any pictures that you gave Sherry to show up on the stream that might explain some of that?
We do. There's a number of things happening in the Chicago area, including a number of projects that CNT is doing to demonstrate how well rain gardens and other green infrastructure work as solutions to water pollution in the city.
So we're doing it here in the Chicagoland area?
Absolutely.
Oh, that's excellent.
Absolutely. And the projects that we're doing, we can show you how it works, where the idea is to reconnect the landscape of cities back to the natural drainage that's possible within healthy soils and in the ground and natural cycles.
Yeah, because in Chicago it was predominantly all wetlands.
It was originally wetlands, so the water would have sort of settled in a place and stayed there for a while. And wetlands are another type of green infrastructure that's very, very effective at filtering out pollutants and one of the most effective techniques for filtering out nutrients.
Can Sherry bring out some of these pictures that you gave us to show? Is it proper now or later on?
Sure, this is a good time. So this is a project that we have that was done on the south side of Chicago in the Jeffrey Manor neighborhood. Okay. It's one of a group of demonstration projects that we are doing to figure out how well it works in the Chicago area. These things have been tested and proven all over the country.
Well, you came from the Pacific area.
Sure.
Right?
Seattle and Portland, places like that, are now using this as their main approach to doing water infrastructure in their cities. We want to bring those ideas into Chicago and show how well they can work here. So in this case, we had a parking lot that was a lot of problems with flooding. Anytime you had a serious rain, the water would just collect in the middle of this parking lot. And during severe floods, that water would flood into the basement of the nearby church school at the Our Lady Gate of Heaven Church. So what we did, and you can see in the picture, my colleague Bill Eyring is one of our engineers. Yes. We designed a large rain garden, or a vegetated swale is another name for it, in the middle of that parking lot, so the water will now drain into that swale through the soil and plants and back into its natural water cycle by bypassing the concrete and bypassing the sewers.
Okay, so this is the first picture. What's the next picture that Sherry might show?
So this is a picture as the garden was being excavated. This is Professor John Tandrich from Dominican University, and what he's showing there is the top surface is the paved parking lot. It's typical of a regular parking lot. You have concrete and then other layers of what are called impermeable surfaces. So that the water cannot flow through that. It cannot reach the ground.
Because of the concrete.
Because of the concrete.
It looks like you got about 6 inches or a foot of concrete there.
A foot of concrete and also a lot of slag, because down in that area of the city, the waste product from steel production covered almost the entire city and made another layer that was hard for water to push through.
So when it rains, the water just stays on top.
Stays on top, collects
through.
Pollutants, or runs off into the street and becomes stormwater pollution runoff.
Well, that's a good depth there that you have there. It must be, what, about 2-3 feet?
2-3 feet of sand right below that concrete. So you have a surface that won't let the water get through, but right below that, a lot of soil that can absorb almost as much water as you want to give it. So in this case, by opening up that surface of the parking lot, putting in rock and healthy soil and plants, we establish a mechanism whereby the water can reconnect with the natural cycle. And in this case, you can see the folks working on this project were from the City of Chicago's Green Corps program.
Green Corps?
Green Corps. And that's a work training program for ex-offenders. And they were our partner doing the construction of these projects. They do a great job. And it's also a good example of how green infrastructure not only can help reestablish better natural conditions and environmental quality and water quality, but it can provide jobs for people who are building these new types of infrastructure and adding to the function of cities and keeping water clean.
You know, I think that's the key, is that a person or a family or an organization wants to go green infrastructure, and they don't know how to do it.
That's right.
Or maybe they'll say, who can we come and do it for us? And here your program is starting with training workers how to do it. You have a design already that will change in different situations what to put in, and it's working. Now, what's the finished product after that? Do we have a picture of that?
We do, and what you can see in the finished product, this is the planted rain garden or vegetated soil. It's also known as a biofiltration cell because it uses biological processes to filter out those pollutants. So
and the biological process are the plants?
The plants and the soil. There's this biotic community, the bacteria in the soil that actually consume some of those things, particularly the hydrocarbons, the types of pollutants that come off of cars, car tires, car exhaust, and the lubricants, grease and oil that come off of cars. So very common things you find in parking lots.
And is your garden, your rain garden, that's called a rain garden, are you providing, you're not providing any fertilizer or pesticides or herbicides?
No, these systems are designed to use native plants as one of the mechanisms. And if you look back at that picture, you can see a couple of metal pipes toward the end of the rain garden.
Sherry, could you bring up that picture?
Right. So those metal canisters in there, those are containing monitoring equipment. So we have wells that are dug into the rain garden, measuring how much water they absorb. And we know from the tests that have been done in other places like Portland, Seattle, Maryland, Minnesota, Milwaukee, almost everywhere that these practices have been put in place, they can remove 90% or more of the volume of stormwater. And in some cases, 90%? 90% of all of that water that comes into a rain garden is going to get absorbed into the ground or more. And also,
that's excellent.
You get pollution removal rates that again can approach 90% depending on the size of the feature, the design of it, and the type of material that's in there. So very high efficiency at removing pollutants, very high efficiency at capturing the water, keeping it out of the sewers, reducing local flooding, reducing all of the negative impacts that you can get from stormwater when it hits cities in their current condition. By using green infrastructure like this on a broad scale, making it a part of the planning and the actual systems that a city or a community uses to manage the rainwater, that water turns into a resource and gets reestablished as clean water. And the monitoring that we're doing on these demonstration test projects will show how well it works in Chicago and confirm what we suspect, that it will work as well here as it worked in all those other places.
And you know, you're providing, as I mentioned, you're providing education. Eventually, it could turn into a job for the workers, and a job to these. You mentioned ex-convicted that are out trying to find a job. You're providing less water coming into our wastewater plants because we have combined sewers in the city of Chicago.
Right.
So you're eliminating that. You're providing help to our water cycle because we depend on our water cycle to provide us water for drinking purposes.
Right.
And also you're providing a place to remove pollutants in a parking lot.
Right, and all communities are responsible under the Clean Water Act for doing this. We have to find a way to increase the quality of the water. We have to find a way to prevent pollution, and green infrastructure is not only very effective at that, but very cost effective as well.
You know, if there's any companies out there or corporations or anyone that is thinking of redesigning their existing or planning a new one, I think they should contact Steve
That would be a great idea.
at Center for Technology to show them how to help the planet, help their employees, help their community, and help everyone in solving our water, because water is going to be very precious, they tell me.
That's right. Water is extremely precious now, and the more of it that we can run through green infrastructure, the more of it we're going to have, because some of that water does seep into the ground and recharge aquifers.
Right.
It's a way of reducing the amount of water we take from the lake, so that it's potentially helping us with our water withdrawals from the lake and the quality of water in the lake, because stormwater runoff, as people in Milwaukee, the Milwaukee Sewer District has found, they can get sewer overflows and contamination in the lake even when they have a deep tunnel system in place capturing most of the sewer overflows. So stormwater, even if you're capturing some of the sewer overflows in the sewers, stormwater can still affect things like the lake, the rivers, and water quality more generally. So you have to do it together with conventional systems.
That's right, because recently here in the Chicagoland area, in the paper a couple weeks ago, we've been reading about all the pharmaceutical drugs, the pesticides in the lake. And you know, the problem that reading these articles is that they identify we do have a problem, pharmaceutical drugs or pesticides, but no solution. And I think Center for Technology has some solution for removing some of these pollutants.
Right. I mean, it's all about pollution prevention.
Yeah, prevention, yes.
And the idea being also that when you capture raindrops where they fall, that water can become a resource. If you put it into a rain barrel or a locally stored system, you can use less tap water or less treated water to water your garden, for example. And there's an environmental cost to that, because it takes energy to pump that water, it takes chemicals to treat the water, and the less water that has to be pumped and treated, the less environmental impact we have from our water use altogether. And we can leave more of it in the lakes. We can dispose of less of it in the rivers and the waterways as sewage effluent.
And you know, you mentioned the word that I always like to hear, prevention, because I think it's cost-wise, it's less expensive for prevention than at the back end to try and treat it. You're treating prevention, but here at the district, we try and do something for prevention, because if we have to treat every pollutant that we have in the wastewater plant, it would cost us a fortune. So groups like your group, is helping us at the prevention end, and this saves the taxpayer money. And this is the next question now, on costs. Have you ever compared the cost of conventional design versus green infrastructure design like that as you're doing?
We have, and what we find consistently, again, across the country as well as in the Chicago area, is that green infrastructure can save money. The idea is that the more green infrastructure we put in the ground, the less water you have to, or the less money you have to spend on conventional pipe and gutter sewer systems. So the more of the water that actually soaks into the ground or is slowed down or captured by green roofs, by rain gardens, by rain barrels, by all these different approaches. What's on the screen now is a very good example from the city of Seattle, showing how they reduced the width of the street, so it required less pavement. They didn't have to build curbs and gutters, and by eliminating that conventional infrastructure,
no curb and gutter?
No curb and gutter. It's not necessary, because the water is flowing across the street margin into those gardens along the edge.
And absorbing all the water is absorbed on them.
And this is one of the ones that showed a 90 to 99% reduction of the water that's running off those systems.
Now,
So
in that street, there's no sewer, no storm sewer, or
not in that street. No,
Not
it
in that
doesn't need to, because the size of the gardens and the depth of material in those gardens is size that they don't have to have it. There are other systems where you can put an overflow pipe so that in an extreme storm event where the water is going to be too much even for the rain garden, the overflow from that system would go into your conventional sewer system. So you have both sort of the double protection of conventional sewers with the very highly effective green infrastructure approach. But because you don't have to build as much or the same length or extent of conventional sewer systems, green infrastructure comes out less costly on the front end. And then what we've looked at CNT, we have an online calculator called the Green Values Calculator,
yes,
which compares the cost of green and conventional infrastructure and shows that in the long run, over the life cycle of a sewer system, over the life cycle of a development, for example, you save money because green infrastructure will also reduce the cost of maintenance. It's easier to deal with systems that are on the surface of the ground. You don't have to do as much excavation. It's landscape maintenance, which has some cost, but not necessarily the same complexity or intensity of cost as doing maintenance of buried systems, and you don't have to pay for as much concrete. And again, this bears out across the country. The EPA did a recent study on comparing just the front end costs, not even life cycle costs, of what are called, these are also called low impact development practices. So when the EPA looked at over maybe a dozen or 15 low impact development projects around the country, comparing them to conventional projects, they found that in all but one case, the low impact development or green infrastructure approach saved between 50 to 80% of the cost, and that's just on the construction end. So this is highly effective because the plant material, this is an example from the city of Portland, where again they found that using green streets, plantings, planter boxes, rain gardens on the street margins or on the sidewalk in the right-of-way becomes a highly effective cost-saving measure. In Portland, they think with some household measures like downspout disconnection, green streets will save them 40% on the cost of stormwater treatment in the rights-of-way, and you get all these other community benefits. Water quality, you get more beautiful streets because you have plants and trees and flowers where otherwise you would just have concrete. And you also get the community involvement in education. Getting people involved in green infrastructure is one of the key benefits.
well, that's key. Education is a key.
Education is a key, and the idea being that people want to be part of the solution. People want to find ways that they can feel like they are doing the right thing. We all want to have a cleaner environment. We all want to have cleaner natural resources, and green infrastructure gives you the opportunity to do that.
Now, here in the, let's talk about Chicago. We're all built up. We have streets with curb and gutter. We have combined sewers. You know, what do we hear? Do you have a solution for the city of Chicago or any other community similar to Chicago, South Cook County? You know, where we have 124 communities.
Right.
In Cook County.
Chicago and a number of the other communities are already working on this and doing what they need to do, looking for places where they can use new street designs, more sustainable streets where stormwater management through green infrastructure is part of the street design. So the city of Chicago has a project going in at Blue Island and Cermak over the next year or so, where they're going to use the right-of-way, use what's now just a plain grass area to put in rain gardens and swales and drainage, using permeable pavement along the edge of the street. So before that water ever gets to the sewer, it has a chance to filter through the concrete, the permeable concrete, and run down into the ground instead. All of these things, although in the experimental sense may cost more, in the long run will cost the city a lot less. So
and why would it cost the city a lot less?
Well, again, you either have to find a way of capturing and treating that water in a conventional sewer, or you have to use natural drainage processes through green infrastructure to deal with it on a local basis. The cost of doing expanded or repaired sewers and treatment systems is high. It's very expensive, like you say, to do the kind of treatment and pollution removal once the water is contaminated. Instead, if you use green infrastructure, you can save some of that construction cost, save on the repair and the maintenance of extended systems. This is particularly true for the areas that are expanding, but even in areas that are built up, green infrastructure can have a benefit as far as saving on system construction costs and maintenance. And also, there's a positive benefit to it as well. What other studies have found in other cities like Philadelphia is that when you have green infrastructure in place, the value of surrounding properties goes up. And when you have the value of surrounding properties going up, the tax base for that area increases and the city has more revenue to maintain infrastructure. So it's a way of enhancing community life, enhancing city's revenue while dealing with the stormwater pollution problem.
Now, all this gardening that we're doing to collect all this stormwater and remove all the pollutants, it's all natural. You're not putting any fertilizer or using any pesticides or herbicides?
No. The idea, again, is it doesn't all have to be native plants, but we try to rely on native plants because they're more resilient to the kind of changes in weather that you get. The idea is not to put out a system where you have to water it constantly or fertilize it to keep it alive, but have plants that are going to live through the natural variability of the climate we have here in Chicago. They'll still be beautiful because they can still be flowering plants, and you can also put in cultivars that are decorative. But the idea is that the native plants also have long root systems, so they can dig their own way into the ground, increasing the amount of water that infiltrates and also just capturing more of the water so they don't need to be watered or fertilized as much.
And also this probably helped the climate change, or global warming.
Right. The other things that we find through green infrastructure is things like green roofs can save on energy use. It's a very effective conservation measure because the soil and the plants on top of the roof and the water that they hold actually reduces the amount of energy it takes to heat and cool a building.
Yes.
Particularly during summertime, green roofs can be 40 or 50 degrees cooler than the same roof area, and the city has measured this with infrared cameras. It's really dramatic to see these pictures. You see a hot, like on City Hall, it's perhaps the world's most famous green roof, right? Everybody knows the City Hall in Chicago green roof. Right next door is the county building, and in these pictures that the city took with an infrared camera showing how hot those roof areas are, the city is green and it's cool. The county building is hot and red because there's no insulation there from the green roof. So that's one thing, is that green infrastructure can help reduce energy. It can cool the surface or cool the roof and cool buildings. And just by reducing that energy use, you're reducing the carbon footprint of the building and its heating and cooling demand. So there's an energy savings from that as well.
You know, there's a question that what keeps from happening from moving from conventional to green infrastructure?
Well, it's partly what you said. It's a matter of public education, getting people, getting developers, and getting municipalities aware of how green infrastructure can become part of the infrastructure planning and implementation for a city, and also making rules in terms of stormwater management and infrastructure development that allow for green infrastructure practice.
And this is what CNT is doing.
We're working with the communities to do that and make it happen.
To keep it healthy and beautiful.